joining us is Bill McKinnon. You're a planetary scientist at Washington University, part of the science team for the New Horizons Pluto flyby, right?
Yes.
So 9.5 years in the making. How nervous were you as that moment approached?
I was both nervous and not nervous at the same time. And I'll tell you, when we went into it, things were working just fine. We were getting new pictures. Pluto was getting bigger and bigger and bigger in the windshield. And then that thing happened on the 4th of July weekend. I got a call. I was at my sister's house because we had basically the day off except for the spacecraft team. And they said, the spacecraft is safed. And we're going, what? Which just means that something happened and it stopped doing what it was doing and it was now just pointing at the Earth, awaiting further instructions.
That wasn't part of the plan.
That was not part of the plan because it interrupted the data-taking sequence, and you don't know what's going on until you find out by querying the spacecraft, and it takes 4.5 hours to send the signal up, 4.5 hours to get the answer back. But we did get back on the timeline just in time to join the actual encounter with the Pluto system. But that meant that we were no longer sanguine or overconfident that everything was going to work just the way we planned. And there's this moment, because when we go by Pluto, we spend all our time making observations of Pluto and its 5 moons, and we don't point at the Earth and tell the Earth anything. So we don't know if it worked. And so when the moment came when the spacecraft finally has sort of done its main job, it turns back to the Earth just to say, hi, I'm okay, here's my system status, basically my flash drives are full of data. When that moment came, everybody went kind of nuts, basically. There wasn't really much of a dry eye in the house.
Yeah, that wasn't an exaggeration, what we read about the excitement and the thrill for you guys.
Yeah, we would have been excited, but knowing that something might not work made it extra special and, of course, extra gratifying to everybody.
So the thing about Pluto is that over the years we've gotten a few images, and then there's that Hubble telescope image, which looks like it's almost like airbrushed. What, as you began to see what Pluto was, what's coming into your mind?
Well, that it's really more complicated than we hoped. I mean, you always hope you're going to find a really interesting place with lots of strange geology and things you've never seen before. But it could always, in nature, you never know what's going to happen. It could have turned out to be a cratered ball, which would have been interesting scientifically, but perhaps not as spectacular as we would have liked.
Well, that's sort of what I was thinking as a layman, that this is sort of like our moon out there. Cratered because it keeps getting hit by stuff, but it's not really doing anything besides just orbiting. But it's much more than that.
Well, Pluto has this advantage, The moon, as everybody knows, is covered in craters. You've seen lots of pictures. We've walked on its surface. But Pluto is out in deep space, and its surface is not made of rock. It's made of ices. Water ice is actually the bedrock. It's the immobile bedrock, and there are all these other exotic materials on it, things that we could hardly conceive of. Frozen methane, that is, natural gas. Frozen nitrogen, which is our own dominant atmospheric component. So these form massive layers of ices that are actually mobile. So when we go to Pluto, even far from the sun, there's lots of activity. There's an atmosphere, and there are hazes, and there's flowing glaciers, and there's faulting. So it turned out to be a geological wonderland. I would say it's easily as complicated as Mars. Not as complicated as the Earth, of course, but
But the thing about this, these changes that are going on, and again, there are changes taking place over millions of years, but there's still changes. In my mind, that needs to be fueled by something. And on Earth, we have this molten core that moves things and changes the Earth's surface and all of that. What's happening on Pluto that drives these changes, the viability of this surface?
You've hit on a really interesting question. One of the things we're really talking about now, and I don't have a final answer, let's say, because in fact we're going to see a lot more of Pluto in the months ahead when we get more data. But you might think of Pluto as an icy world, and it is icy on the outside, but it actually has a lot of rock in it. Like more than half of it by mass is made of rock. And rock has radioactive elements, normally uranium and stuff like that. And this releases heat slowly. So we do think there is heat leaking out of Pluto, and that can drive a lot of its geology. What we're worried about, if you like, is whether this is enough to make the system go the way we see it going right now. So we're kind of scratching our heads, and we have some ideas that may or may not pan out.
So I've got these pictures that I've downloaded like
Okay.
everybody else is.
Yeah.
I'm looking at, and one's labeled ice mountains.
Yes.
What does that say to you?
Well, it says that some process made mountains on Pluto. Across the solar system, mountains on the Earth are made by, plate tectonic forces. Mountains on the Moon are made by impacts. Mountains on the Earth and on Mars are made by volcanic processes with ordinary lava, not water. What made these mountains on Pluto is TBD at this point, but something did, and we don't see impact craters on them, so we know it didn't happen billions of years ago. I can't really tell you how old they are, but they're only a fraction of the age of the solar system, let's put it that way. Yeah.
And there's this picture, the Sputnik planum.
Okay.
And it's a flatter surface with these let's say rivers, but they're not rivers, but they're divided.
Yeah, these are sort of like divided little ovoids or polygons. Here we think we're looking basically at a flat sheet, a thick flat sheet of solid nitrogen ice or nitrogen ice of these other crazy ices mixed in. And we think actually this material is slowly moving up and down, roiling. And those little dividers, those things that look like rivers but really form a connected pattern, are where the material moves together and descends back into the sheet. So this we think can be powered from the heat coming out of Pluto because these ices are so soft.
So these are like glaciers?
Yes, they're like glacier ice, but on Pluto. So it's not made of water, it's made of solid nitrogen.
Let's talk about the largest moon, Charon, right? As I'm looking at the image here, it looks really big.
Well, moons form in different ways. And if you look at like the satellites of Jupiter or Saturn, there's a whole system. It's like a miniature planetary system that's around these gas giants. But there's another way we think that we can form moons, and that is through collision. So if you have two large bodies early in the solar system that approach each other slowly enough, and they smash together, and they ultimately end up maybe with two bodies going around a mutual balance point, which we call a barycenter. And that's actually the dominant theory for how the Earth's moon formed. And so the Earth's moon is maybe 1% of the mass of the Earth. Charon is more than 10% of the mass of the Pluto, Charon system.
And there's interesting things going on as well. I mean, I'm looking at the picture, there's a dark spot on the side at the very edge of this. There's what's being called a deep canyon.
That particular great image was returned as a JPEG, basically, and if you blow it up, if you get it online and blow it up, you'll see the artifacts. But we're going to get it down lossless later this year, and that dark spot is actually at the North Pole, which is really interesting. So some of us think it might be a giant crater formed, a basin basically formed long ago, but we can't quite tell yet until we get that better lossless image.
One more image I want to talk about, and that's that silhouette as the spacecraft is heading past Pluto looking back. And you see what looks to me like the atmosphere. It surprised me to see that image.
It is surprising, I'll tell you why. We knew it had an atmosphere, right? But we knew it was a very thin one. Like Mars's atmosphere is very thin. In fact, it's thinner than Mars's. We could tell that from the Earth because we could watch stars go behind Pluto and we could see how the light would dim out slowly. But it was such a thin, tenuous atmosphere that we really didn't anticipate seeing a picture like that. And so what you're actually seeing is not the gas molecules, not the nitrogen in the air there, if you like, but little tiny particles. It's hazy. And you don't see the haze looking directly on, but when you look back with the sun behind Pluto, you see that kind of like you're at a show, with the smoke on stage and stuff. That's what you're seeing. And it's really extensive. And all of the atmospheric scientists on the team were amazed. They say, I can't believe there's so much haze and it extends so far away from the planet. So it's a really big surprise for those people who study that. And it's just a beautiful picture. It's kind of like, hey, we were really there. You can't get this picture from anywhere else.
You've got some answers. You've probably got a lot more questions now. What's the most baffling question for you right now about what's going on Pluto?
There are two. One is the one we've just talked about, is like what's powering the activity on Pluto today? What's the secret of Pluto? That's what we're trying to get at. And of course, on a more specific level, we want to see really the rest of Pluto's surface in this better resolution that I talked about to really understand how active it's been in different places and how extensive this nitrogen glacier has been, because it's not what we see now is Pluto today, but we're really interested in how Pluto evolved.
I know you get this question all the time. In fact, when I said I'm going to interview you, people said, oh, ask him, is it a planet? Is it a dwarf planet? Is a body in the Kuiper belt? Does it matter?
All of the above is my answer. But if we ask Pluto, Pluto will say, I don't care what you call me, because Pluto is the biggest body we know of, the most complex body out there in the Kuiper belt. It's also the brightest to our telescopes and the one closest to us on Earth, and so the easiest one to reach with a spacecraft.
So if I want to call it a planet, you're okay with it?
I'm okay with it, but and we could also call it a dwarf planet, because that really sort of says what it is. It's a small planet. There's a whole bunch of these small planets in the solar system. It's a whole new class, basically. It's not a lone, Pluto's not a lone dog anymore, if you like.
It's just the first one.
It's the first one, that's right.
There's lots more stuff coming, right? I mean, we've seen, maybe a dozen interesting images online and things like that, but you've got a lot more stuff that's going to come from New Horizons, right?
Yeah. People here on Earth, all of us, everybody has seen basically all of the images we've been able to return so far. The bit rate from Pluto, because of the size of the antenna and the distance from to the spacecraft, is only on the order of 1,000 or 2,000 bits per second. So it's like a really bad landline connection from the 1980s. So it's going to take months to get done all these pictures, and we estimate that we've only returned about 5% of all of the data and 5% of all of the images. So starting in about mid-September, we'll probably be getting good images almost every day for months on end. And so if you think this stuff is interesting, there's a whole raft of stuff on here that's of incredibly better resolution than you see. We're going to plaster the planet with these high resolution images, and we'll really be able to see the details of those mountains and of those glaciers that I mentioned earlier, that kind of business.
Thanks for joining us. Appreciate it.
It's wonderful talking to you.